everyone, I am Dr. Sonal Jain from Department of Anthropology, University of Delhi. In this series of forensic science lecture, today we are going to discuss about the soil formation, the analysis of soil, the examination of soil evidence and why it is important in forensic science as a major evidence. So, when we are talking about the examination of soil evidence, we should first look what is soil and how the soil is being formed. So, soil formation is a very time taking process. It begins with a parent material which determines the mineral composition and it contributes to the chemical and physical properties of the soil. There are several mechanisms which are involved in soil formation. The first is weathering, the second is accumulation of materials, third is leaching, fourth is transformation and fifth is calcification of the rocks. So, we are talking about the various factors which leads to the formation of soil. So, starting from weathering, it is the breakdown of rocks and minerals at or near the earth's surface which results into products that results in equilibrium with the conditions found in this environment. So, whenever there is any disintegration in the rocks and minerals which leads to the mineral content and which further leads to the development of the soil. The products of weathering are the major source of sediments for erosion and deposition. Because of the weathering, it can occur because of any physical factors, chemical factors or any biological factors. The physical weathering, it results in the breakdown of mineral or rock material by entirely mechanical methods. When we are saying the mechanical methods, they are the either wetting dry method which is caused by a variety of causes. That could be due to the excessive rainfall or which could be due to the time. Then the abrasion of large rock occurs when some forces cause two rock surfaces to come together. Because of this abrasion, they cause mechanical wearing or grinding of their surfaces. Whereas chemical weathering is the alteration of the chemical and mineralogical composition of the weathered material via chemical means. A number of different processes which includes the chemical process includes the hydrolysis, oxidation reduction, hydration, carbonation and solution which results in the chemical weathering. These are the factors which can help in the disintegration of the rock, the parent rock, which further releases the minerals for the soil formation. After the physical weathering and the chemical weathering, there are certain factors because of the biological weathering. They involve the disintegration of rock and mineral due to chemical or physical agents of an organism. The organism that can cause weathering might range from any bacteria, that means it could be any microorganism or the flora, the plants or animals. These, because of the weathering, the parent material, it gets disintegrated and that makes up the major layer after the bedrock if we go from down towards upwards. So, the bedrock is there and due to result in the weathering, we have the parent rock over the top of that. After that, the accumulation of material started because of the organic material or any decomposing material which results into the new mineral materials that are added to the soil by various forces such as ice, water, wind as they accumulate there over time. In the cases of poorly drained soils, the organic matter accumulates since water logging prevents it from being oxidized or broken down by the soil organisms. However, when we are talking about the well drained soils, the accumulation of material occurs when the root systems hold them up. Particle depositions by the forces of wind, water or ice equally aid in the accumulation of new materials. Some plants, with the help of symbiotic bacteria, they fix atmospheric nitrogen and ammonia compounds into the soil as nitrates. So, that is how the accumulation of materials begins or remain in the soil when the soil is being formed. Then the third and major important factor is leaching. It is the removal of soluble components of the soil column by water. The water washing down through the soil, it carries bases like calcium, which is held as exchangeable ions in clay humus complexes, as well as acidification by the substitution of hydrogen ions. So, through the movement of water, wind, ice, or by the uptake of the accumulated materials by plants, new particles including clay, organic matter, clay silt or other chemical compounds, they get leached and eroded or they get taken up by the plants. Therefore, the physical and chemical compositions of the new accumulated materials together with the soil parent material are altered because of the leaching factor, because of the various movements of the water, wind or ice. Then there is sometimes the transformation, which is the chemical weathering of soil particles including silt, sand and clay minerals, as well as the change of organic materials into degradation resistant organic matter. Following the transformation, the clay and other accumulated materials are washed away from the upper layer and they are deposited in the lower horizons. After we are talking about whenever there is transformation because of the accumulated materials, they are being washed, the materials are being washed away from the upper layers and they get inside into the lower horizons. The soil organisms, for example plants, animals, they are also responsible for the transformation of the soil by the physical and chemical breakdown of material. The soil begins to take shape on its own through transformation, which improves water retention, capacity and nutrient composition. Then the factor which also involves in the soil formation is calcification. It occurs when the removal of water via evaporation as well as transpiration exceeds precipitation, which causes the upward movement of dissolved alkaline salts from the groundwater. Meanwhile, the movement of rainwater, it causes a downward movement of the salts. So, depending upon the leaching, the amount of transformation and the calcification, it results in the soil formation. So, whenever a soil is being formed, there are different layers in that and we call it as a soil profile. It is formed in the layers and these layers are also known as the horizons. So, we see the soil layers. At the top down we have a bedrock, on the top of that we have the sea horizon. Sea horizon is also called as the parent material because it is made from the parent rock. Then we have the B horizon, which is the subsoil. The E horizon is the zone of leaching, A horizon is the topsoil and O horizon is the surface litter, which is the contaminants or the nutrients which are there. So, these layers, when we are talking about, the humus is the O horizon, which is made up of decaying organic matter. Topsoil or the A horizon is the mixture of humus and minerals. Sand and slit makes the E horizon. Subsoil is the B horizon, which is made up of clay and minerals. Broken rock, the C horizon, where very little humus is present, and where we are talking about the bedrock or the solid rock, that we call as R horizon. So, depending upon the horizons, there are different types of soil which we can categorize them into. One is the sandy soil. In this type of soil, they have the biggest particle. The biggest aspect of this soil is they are better draining and they consist of rock and mineral particles which are very small. Silt soil, it consists of minerals like quartz and fine organic particles. To check if the soil you have is slit, you take some amount of soil and rub it between your fingers. If the soil sticks to your finger, then it is silt soil. The clay soil, it is naturally occurring soil and it has very less air space. To check for the clay soil, we take soil sample and damp it into the water and when we feel it between our fingers, the clay soil is very sticky and it retains a very good amount of water. The loamy soil, it is the combination of sand, clay and silt soil. So, to look for the evidence as a soil evidence, we must know what are the different types of soils which are found in India. The Indian Council of Agricultural Research ICAR, they have classified the Indian soil in the following main groups: alluvial soils, black soils, red soils, laterite soils, mountain soils and desert soils. So, depending upon from where the soil has been come, they have been named accordingly to that. The black soils and the red soils are named as per the color of the soil, and the color of the soil is depending upon the mineral present in the soil, or any oxidation reduction reaction occurs in the soil, or depending upon various macro and micronutrients which are present in the soil. So, after learning about the soil formation, the soil profiles, when we come to analyze the soil as an evidence in the light of forensic science, we call this field of soil analysis at forensic geology. Forensic geology will we talk about, it is the legal application of earth and social science. That means whenever we are analyzing any soil evidence, answering any questions related to soil which will helps us in the legal application, then we call it as forensic geology. It retains with the characterization of earthen materials that have been transferred between objects or locations, and the analysis of possible origin or sources must be known, that from where this particular soil evidence has come from. So, to look into the history, in the year 1887 to 1893, the Sir Arthur Conan Doyle, they wrote about the scientific ideas and techniques for solving crimes in Sherlock Holmes, which includes information about soil and its composition, which had never actually been used. Then in the year 1893, there was an Austrian criminal investigator, Hans Gross, who wrote that there should be a study of dust, dirt on shoes and spots on cloth. He observed that dirt on shoes can often tell us about where the wearer of those shoes had last been, then toilsome inquiries. So, along with the shoes dirt, we also look for the dirt on the vehicle from which the suspect or the criminal or victim might be travelling. They can give us the answers from where the persons they are been travelling to, or from the places they have come from. Then in the year 1904, George Popp, a German forensic scientist, he presented the first example of earth materials used as evidence in a criminal case, which is the strangulation of Eva Dish. So, he used as an evidence the soil evidence for the first time where a forensic case has been solved. Then in the year 1910, Edmund Locard, who is a famous forensic scientist who gave the principle, Locard's principle of exchange, he was a forensic geologist. He was most interested in the fact that the dust was transferred from the crime scene to the criminal, and this helped him to establish his principle of transfer. Locard's principle of exchange, which we always read as the basic principle of forensic science, he came up with this idea that the dust can be transferred from the crime scene to the criminal, through which the criminal can be related to that particular crime scene. So, whenever we are going for the examination of soil as in forensic evidence, we have to establish a relationship or link to the crime, victim or the suspect. There are certain physical properties which we can look for or analyze, for example, density of the soil, magnetism, the particle size, mineralogy, that means what minerals are present there. And when we are talking about the chemical properties, we talk about the pH and the trace elements. The probative value of soil is very high as the types of earth materials are virtually unlimited. They have a wide distribution and change over short distances. So, It makes the soil individual at a particular area. If the victim has travelled to a different area, or if the criminal is travelling from a far off area, then we can easily say because the soil changes over short distances. Therefore, the statistical probability of a given sample having properties the same as another is very small, which makes the evidential value of soil to be excellent. Other things which increases the probative value of soil as an evidence is the finding of various rare or unusual minerals in the soil, different types of rocks, different fossils or different manufactured particles which are present in the soil. The minerals which can be found in the soil, they are identified to be 2000 different materials. 20 or so are commonly found in soils. Most soil samples contain only 3 to 5 minerals. So, therefore, if we look for the analysis of various minerals which can be found at a particular area, they might not be found at a different area. And we can characterize this soil for identification on the basis of the size, density, color, luster, streak and magnetism of that particular soil. The rocks, when we talk about the parent material or the different rocks which has helped in the formation of the soil, they might differ from one area to another area. There could be rocks like natural, granite, man-made like concrete, and the formation of these rocks which may be due to igneous, sedimentary or metamorphic. Coming to another aspect which increases the probative value of soil is the fossils which are present in that particular soil. There are certain remains of plants and animals which may help geologists to determine the age of rocks. Some are very scarce and they can be used to identify various regions or locations. So, depending upon the mineral of that particular soil, the fossil remains which are present in that soil or the fossil remains or plants of animals in the soil, they can lead us to the different regions or the location or from where this has been, the origin of soil has been there present. Palynology, another important factor which is never to be missed is the pollens. The study of pollens is palynology, and the spores and pollens which are found in that particular soils make it more individualistic, that what is produced in that given area, what is the dispersal pattern and what is the variation in size and weight of those pollens and spores. So, coming to the analysis, as we look for each and every evidence, we go for the class characteristics as well as the individual characteristics. When we are talking about the class characteristics, the type of soil, they might have similar characteristics at the primary and secondary crime scene or on the suspect or on the victim. Whereas for the individual characteristics, only if the soil has an unusual or specialized ingredient such as pollen, seeds, vegetation or fragments can help us in knowing whether both the evidences or both the soils have been originated from a single place or from the another place. So, if the mineral content or the parent material of two soils might be same, that might go with the class characteristics. But when we are talking about the individual, the pollen, the seeds, the vegetation or any other manufactured fragments which are found, they make the individualization of the soil easy, or it could be helpful looking at all these factors. The sand which is present in the soil, it is the term which is applied to the natural particles. They have a grain diameter between 1/16 mm and 2 mm. Depending upon the colors and contents, the parent rock and surrounding plant and animal life, the color of the sand changes. As we can see in the picture that the sand from 6 different locations of the world, they are so much different that on the basic presumptive test, the color test, we can say that they have been originated from different places. The sand characteristics, when we say, it is based on the material of the source and which gives the sand its color. So, texture is determined by the way the source was transported. the shape, the grain size and the sorting, they are the different sand characteristics. Sand types, when we talk about, we have continental sands, ocean floor sands, carbonate sands and tufa sands. The continental sands, they are formed from the weathered continental rock, usually granite. Ocean floor sands, they are formed from volcanic material, usually basalt. Carbonate sands, they are composed of various forms of calcium carbonate, and the tufa sands are formed when calcium ions from underground spring precipitate which carbonate ions in the sea water of a salt lake. So, as the compositions or the formation of different sands are different, so the color of these sands will also vary. Soil has a major part of different types of sand, which also make it a unique, gives it a unique characteristic, or it individualizes on this basis that how that particular sand formation has taken place. So, when we talk about the sand evidence, the Rachel Carson has said, in every grain of sand is a story of earth, because every grain of sand, the way it is formed in a natural way is very different. So, when we analyze the class characteristics of sand and the individual characteristic of sand, we can find the type of sand, they have similar characteristics to the primary or secondary crime scene on the suspect or on the victim, that comes into the class characteristics, and if there is any unusual ingredient or contaminant, that goes into the individual characteristics. So, for the examination of soil, it can provide useful information about link of persons to crime scenes because of its nature as the surface of the ground. The evidential value of soil stands on large variation in its characteristics. It can contribute to drug intelligence development. For instance, soil taken from containers, ships or trucks is very useful to identify the drug shipment pathway. The soil, it can stuck to the wheels of the various vehicles, and then the sample taken from, we can say that what is the pathway from where that particular vehicle has been travelled. As a class evidence, it cannot be individualized to a particular location, but we can get to know the pathway. For examination, we can go for the presumptive or confirmatory test. For we have various microscopic examination using chemical reagents, particle size distribution, ignition test, density distribution of soil particles, pH measurement and various instrumental techniques. When we are talking about the microscopic examination, firstly, before microscopic examination, we go for the color test, which is an obvious characteristic of a soil specimen. The question specimen is whether originated from the same source or not can be identified if the soil colors differ. Second thing, when we have to determine whether the soil is from the same area or not, they can be determined on the basis of density by using a density gradient test. Density of soil varies over a wide range depending upon the composition of the soil, how tightly it is made and how moist it is and other factors. So, the average soil has a density of about 1.5 gram per milliliter to about 2.7 gram per milliliter. Depending upon how dense the soil is, we go for the density gradient. We make different layers of chemicals, bromoform and hexane, and then all these layers of different density are being made in a measuring cylinder and our evidence is being analyzed into that. So, depending upon what density of that soil particle is, it gets into that layer and we get to know the composition or the density of that particular soil. The particle size distribution can be known by the, it is a characteristic of a soil specimen. Some soils, they are sandy soils, they may have relatively uniform particle sizes with 90% or more of the particles contained with a size range of perhaps 5:1 or less. So, particle size distribution of a soil specimen is an important aspect forensically, providing just one more piece of the fingerprint of that specimen. Another test which we go for is turbidity test, which is a measurement of how cloudy that water appears. Technically, when we define it, it is a measure of how much light can be passed through that water when the soil evidence is mixed through it. So, if we take two soils, different soil samples, and we have to examine them to know whether they have been originated from the same source or not, they have been mixed with water and then light is being passed through it. Depending upon the scattering of light through those solid particles, we will get to know whether the soil has been originated from a particular area or from different areas. Apart from these tests, we can also go for certain instrumental techniques like differential thermal analysis, polarized light microscopy, X-ray diffraction, ICP mass spectrophotometer, ICP OES and SEM. SEM is basically an electron microscope under which we can look for the particle size, shape of the particles of sand, soil. XRD is X-ray diffraction. Differential thermal analysis is one of the technique where difference in temperature of the sample and an inert material is measured as a function of heating block temperature. It is a very common method of determining the kind and amount of carbonate materials present in the fine grained soil. The most common carbonate minerals are calcite and dolomite. They have thermal reaction at somewhat higher temperature than the most important clay reactions. The large amount of heat absorbed in the carbonate thermal reaction in the majority of soils, clay and carbonate thermal reactions, it occur independently. So, when we go for the differential thermal analysis, it has advantages like it is simple, sensitive, rapid and a specific technique. Polarized light microscopy helps us in the analysis of any minerals which are present in the soil, where polarizer and analyzer are used so that only the light component whose vibration direction is parallel to the polarizer is permitted to pass through. Polarized light microscopy is utilized to distinguish between single refracting and double refractive media. Fortunately, few minerals are isotropic and more minerals are anisotropic. So, that is why it can be used for this analysis. Another important technique is X-ray diffraction. This is used for determining the atomic and molecular structure of a crystal, in which the crystalline atoms cause a beam of X-ray to diffract into specific directions, which will give us a graph that will help us to know the exact composition of that particular soil. So, considering the different examination of soil, we can basically relate to where that soil is originated from and whether the two soil samples they belong to same area or not. I would like to conclude this by telling a case study where a 9-year-old's body was found in a wooded area in Lincoln County, South Dakota. A forensic geologist, he collected the soil sample from the fenders of a suspect truck and from the area where the body was found. Both soil contained the grain of a blue mineral which turned out to be a gahanite, which is a rare mineral that had never been reported in South Dakota, which as a result the soil tied the suspect to the crime that they have travelled from a different place. Thus, the individual characteristics which are present in that particular soil specimen helps us in analyzing and answering the questions of forensic science. Thank you.